Excellent. Those were some very nice presentations. I really want to thank all of you for your presentations. We're going to move into an open discussion session now for the next half hour, followed by a half hour of what we're calling observer comments. And I just want to take a minute for the observer comments. Well, let me back up. Then for the next half hour, the discussion will be focused on this theme that we just had a series of presentations on, both the seismicity, any seismicity questions, any geodesy questions or plate motion questions, or just brainstorming on, and in particular, I would really like if we could brainstorm on, do we have data gaps that we could, over the next 1 or 2 or 3 years, because this is a long-term project that has a 4-year lifespan, that we could begin work on now to potentially reduce uncertainty in some of the things that we've been talking about. So the first half hour here will be to discuss our theme session. That'll be followed by a half hour of, as I mentioned, what we're calling general observer comments. And that can be comments on anything that someone would like to comment on. And what we ask is that you sign up in the back of the room for those observer comments, and that the comments are 3 minutes in duration. You can come up to the microphone and make whatever comments that you would like. This is a public workshop, and so comments from the public or any other observers are welcome. But that'll be the final half hour of our meeting, and then we will adjourn the workshop portion of the meeting, and the PPRP can caucus for the next hour after that. And during that time, we will have, I don't know if they're going to reopen this or whether we will all convene in this room or the room adjacent to us, where we will follow up with an hour-long just open question. If you have anyone in the audience, as Norm said earlier, if you have questions on any of the technical issues that we've been discussing, where more of a lay explanation is needed, Norm, I know, will be happy to answer those questions. But anyway, so for the next half hour, and do you have, Marcia has a sign-up list for the, I wanted to give people enough time if they want to sign up for, to come and give several minutes of discussion or comment, please sign up for that.
A
Yes.
question on that. The PPRP or observers, can we also make comments, technical comments? Add comments from observers?
Repeat the question.
Okay, Kevin Coppersmith asked the question, as members of the PPRP, can they make observer comments? What I would, I've mischaracterized the observer comments they can be technical or non-technical. This is an opportunity for the public to come up and speak on whatever they would like to speak on. I guess the PPRP can also sign up and give a 3-minute comment. You're a member of the public. But for the next half hour, and I'm already a few minutes into that, I really would like to focus our discussion on the theme session that we just had, covering a wide variety. I know it's seismicity to geodesy to plate motion, but so I'd just like to open it up to any comments or ideas or questions that anyone might have for any of the speakers, or just your own personal observations. Does anybody have any? I would like to, Catherine, yes.
I guess I had a question. Wayne showed some of the sort of seismotectonic models for explaining possible deformation sort of regionally with the rotation, block rotation. We've speculated on step overs. Jeannie Hardeback had, Wayne showed a model she had presented with some tectonic escape at the southern end. And I was just wondering if Jeannie or others had any comments about the new information that was presented by Sarah showing possibly this relationship with the creeping section and more convergence in the north, if any of this new data supported or was consistent with their models. I guess just overall, kind of conceptually, if anybody has any comments on that.
Sarah? Any comments? Wayne, unfortunately, just stepped out.
I guess I can comment, but I think kind of the key part of that model of mine that Wayne was showing is that I was considering that some of the compressional deformation is actually just in a step over between the Hosgray fault and faults further inland. That as the slip rate on the Hosgray fault decreases to the south, that there would need to be then sort of a left step of right lateral strike slip motion across the area that would lead to kind of this compressional zone. And I think it's not clear to me that sort of a internal deformation like that actually takes up any plate motion to solve any of this problem of where the extra plate motion is. So yeah, I think maybe this is something we need to think about for the next workshop when we're actually talking about models instead of data.
Proponent models. I know the deformation in the crustal convergence that we're observing in the Central Coast ranges could be plate normal driven convergence related deformation, or it could be fault interaction related convergence, such as you've indicated. Is that, Catherine?
Yeah, I
What?
just realized I crossed a shack.
Into proponent models. But I would like to open it up and maybe just it's easy. And first of all, I'd like to say as part of the shack due process of law, it's important that, I mean, for example, we've read Jeannie's papers and Sarah's papers, and we're familiar with data that are available, but it's important in the context of the shack process that all of this information be presented. And so it's been very nice that we've, that our speakers have come and presented their data, because we need to bring it into the shack review process so the PPRP can review the considerations and evaluations that we're doing. But it's easy to talk about data we know about or that are available and that we have presented to us. What's hard, as I mentioned earlier, is what data don't we have that we can improve either the current research that we're doing, or that can improve and address the significant issues that we talked about earlier, of which, as Norm and Katie mentioned, improving our understanding of the Hosgray, primarily its slip rate and dip, the Los Osos fault, primarily its geometry and sense of slip, the shoreline fault, and the San Luis Bay fault. Also, what is not in our model are there potential thrust faults or detachments that we have not recognized yet. So anyway, I'd like to throw this back to, say, Sarah and to Jeannie and to Marcia. Wayne has stepped out, to Jeff Unruh, and to our speakers. Are there data that are in your, are there data gaps right now, serious data gaps that really could improve our understanding if we would just focus a couple of years of effort on? Anyone? Jeannie, I know I've kind of already touched on this with a number of discussions, but I'd really like your thoughts on this.
So in terms of the seismicity, the problem with filling in data gaps is really just sort of the low seismicity rate that, even if we went out and put out sort of a perfectly designed seismic network of arbitrary large costs.
We need more earthquakes.
We need more earthquakes. We would be waiting for another couple of decades. So in terms of this sort of kind of 4-year timescale, I think PG&E has made some really nice upgrades to their network, switching to these digital stations and the OBS stations. But it's quite possibly going to take decades to kind of get the fruits of their labor from that.
I would just interrupt, Bill. The long-term plan is the long-term seismic update ends in 4 years, but it'll be redone again after a few more years. So that the question is, well, maybe we don't get much out of it in 2 or 3 years, but what about 15 years?
I think in 15 years, certainly whatever network upgrades are made now, we're going to, over the next 15 years, we're going to have enough data to see the improvements for that. So in terms of, thinking the simplest thing of just where to put stations, I think one of the biggest onshore gap is basically south of Oceano. That
besides offshore.
But besides offshore, and then offshore is really the big problem because those 4 OBS stations are nice and they're going to help with figuring out the seismicity locations in that little area that's important to see what the junction of the shoreline and Hosgray faults looks like, but that's a very small area, and the effects of that small OBS network aren't going to help with all of the rest of the offshore area. And there's a lot of questions out there in the offshore, that there's a lot of seismicity out there sort of on the Santa Lucia Bank fault and Queenie structure and all of those structures out there that because they're so offshore, they just look like fuzz. We can't make out any structures out there at all. And those are, even though those are kind of outside of Norm Abrahamson's niggling zone, it's possible that sources off there could be sources of local tsunamis and, other issues that we need to get a better handle on the faults out there. And so, I don't have a sense of what's kind of financially or technically feasible for PG&E to do about additional OBSs, but there are certainly lots of other potential targets for OBSs out there, and as Wayne brought up, ocean bottom GPS also, not just in terms of figuring out the slip rate of the Hosgray fault, but looking at some of these offshore structures and sort of figuring out what their activity rate is and thinking about whether those need to be considered, whether those need to be brought up out of the niggling zone and whether those could be tsunami hazards. So the whole offshore is this completely instrumented mystery, and I think there's tons of things you could do, but I think all of it is going to be obviously a lot more expensive than on land. So I think.
But could I follow up on in part on this issue and get back to your presentation, because I was left kind of confused a little bit. PG&E is considering, Marcia's program, she's considering placing 4 ocean bottom seismometers offshore in the local area near Diablo Canyon. That, and then you sort of did a fast forward analysis. What would that help us? And it'd be a 30 to 50% improvement in location certainty. Right. And as you were just saying, but that leaves a whole bunch of the offshore where if we had where we have really poor locations. In the Diablo Canyon area, we still have pretty good locations. You detected the shoreline lineament without this improved. The question I have, are we misapplying our funds to put in 4 ocean bottom seismometers in that local area near Diablo Canyon, or should they be more scattered elsewhere to sort of improve the greater resolution of data?
Well,
or events?
I think it depends on what you're considering the important questions. And if we think back to kind of this morning's sensitivity analysis, that there did seem to be some sensitivity, although these were not the largest sensitivities, in terms of whether or not certain faults could rupture together and what the full lengths were. And so this particular set of OBS is, I think, really going to help us with the questions of, is the shoreline fault segmented, and what does that intersection between the shoreline fault and the Hosgri fault really look like, and should we be considering shoreline Hosgri ruptures? And so I think this OBS deployment is very targeted to one particular question that is, one of those, non-trivial but not the most important sensitivity questions. And the sensitivity questions are things that we can't actually address with seismic networks, like slip rates. Are some of the things that are largest sensitivity. So I think in terms of that OBS network, it's going to be very helpful answering a very specific question. In terms of trying to instrument the rest of the offshore, I think this is getting more into that we might find something we didn't know about that we don't know right now, because we don't know a lot about the offshore. Maybe we don't know right now that's important, but if we did do more instrumentation in the offshore, we may come across something that raises to the level of kind of popping up above the niggling line and becomes something that we should be talking about.
You've raised the possibility that there may be seismicity lineaments offshore extending across Estero Bay. Now that is a bay, and maybe we have more coverage because it's in a bay, but would we be better off putting an instrument in Estero Bay to better define those features?
I don't know. I mean, I could do kind of a similar study of, putting, I could do an infinite number of studies of putting OBS deployments in various places, and I kind of haven't gotten around to do that. But I mean, Estero Bay does have pretty much anything that's right along shore. You at least have the benefit that you're likely to have a few stations within a few source depths of the earthquakes. And that's something that's just as important as having coverage around the earthquakes, that you do need some stations within, 1 or 2 focal depths of the earthquake. So when we're talking about along shore, we do have some control over those locations just from the onshore stations. But when we really talk about these really far offshore structures like Santa Lucia Bank and Queenie structure, we're talking about earthquakes where you don't have, there's no station within, 30 source depths or something. And so we're talking about earthquakes that we have sort of a vague idea are out there in a cloud, but we have no ability to really see the structures in those clouds of earthquakes at all. So, I mean, just in terms of scientific curiosity, maybe somebody might decide that it would be more important to instrument those far offshore structures. But in terms of, if you're really just focused on what's going on right around Diablo Canyon, maybe the OBSs near Diablo Canyon are a better investment. And I think, I don't think I can answer that question of what's a better investment. I think it just has to depend on what questions people are trying to answer.
Okay. Yeah, Steve?
Yeah, Jeannie, I'm going to ask you to comment on something else as well. And
maybe Marcia could comment on this.
And Marcia. Okay, for both of you, it seems that we recognize that for this round, we have a data set, and it's unlikely that in the time frame of this project, that data set's not going to change substantially. There'll be some improvements to the velocity model. And so the temptation is going to be to interpret that, push our interpretation of that data set as hard as possible. And you brought up some really good points with really keeping in mind the uncertainties in the locations, and so not trying to overinterpret the best mechanism data or the best location data. It brings to mind a paper that Jeff Unruh had brought to my attention by Egil Hoxson. And I don't know if you're familiar with it, but he was looking at Southern California, mainly strike-slip faults, and he was looking at patterns of seismicity from the interseismic period, main shocks, and aftershocks. And one of his main conclusions, I believe, was that the interseismic, the inter-event seismicity is around those main rupture planes, but the best locations don't seem to indicate that those inter-event earthquakes really align on what's going to be the primary slip plane. And so there's some uncertainty in my mind about if these are small earthquakes, are they occurring on small patches of a larger fault, or are they occurring on small faults that are in the damage zone, but are not necessarily the best representations of where the actual main shock zone is going to be. So can you comment on that?
Yeah, I've seen that study. I mean, I think there's an issue with seismicity studies that Southern California and Northern California really look like different beasts in terms of whether or not the microseismicity is occurring on the major faults. That, you know, I've seen Ale study. It's a very nice study, and there have been, you know, other people have pointed this out prior to Ale, that there's really not a whole lot of seismicity occurring on what we think are the fault planes of the major faults. In particular, the San Andreas itself seems to be sitting there really quietly, as compared to kind of the major faults in the Bay Area, where it does appear that, you know, quite a lot of seismicity is occurring on what we think is the actual fault plane of the Hayward Fault and some of those other faults. So I think that's...
That are creeping in some
right.
cases. This
That
is
are,
possibly a difference between creeping and...
it is possibly a difference, yeah. So, it is possible that, I mean, the kind of the linear seismicity zones that we see in the Central Coast, a lot of them are along the Hosgri Fault, and the Hosgri Fault, I guess, appears to be a fairly wide kind of zone of multiple strands and damage, and so it's not clear to me that you could say, are these earthquakes occurring on one or multiple strands, or are they occurring in some sort of broader damage zone? I don't think that, you know, given the 1 kilometer, plus or minus 1 kilometer uncertainty of the locations, I don't think that we're going to be able to say anything other than these events are occurring in a Hosgri Fault zone.
Marcia, did you have?
Yeah, I just had a couple comments. One about the velocity model, which we brought up earlier, about getting a better 3D velocity model. And Stu's going to be giving his presentation tomorrow on the offshore plans for the offshore data gathering and also what we've already gathered. So there's going to be a lot of new information coming in, and a lot of that will be able to be used to help constrain the offshore velocity model. Secondly, I'm more hopeful of what we're going to get out of putting the OBSs. And the reason is we've been upgrading these other stations onshore. And one of the things that we observed was we have the earthquake data feeding in automatically, and we have it plotted out and on a map in a tool called Map Guide. And we noticed that we can tell when the earthquakes have, stations have been updated and they're now online, because all of a sudden we get clusters of earthquakes, little guys, around our new installation. So we're getting lower magnitude earthquakes. And so we only have 48, maybe 54 earthquakes that make up make up the shoreline fault zone, you know, over 20 years. So I'm hopeful that over the next 5 years, if not maybe even shorter, we might start seeing more little earthquakes. And that's part of the reason why I wanted to put the network in. So just to make that, we may end up getting more data than having to wait 15 years or whatever.
That would be great. We need more earthquakes, that's for sure. Sarah, I have a question. Is there anything that could be done that your team could do to improve the detail of that transect, or the rather than a focus being on the San Andreas, have a focus be on the coastal faults and just where are we getting steps in the deformation rates, you know, across structures? Is there more that can be done, in other words, or more data that is available that you could incorporate into your model in the coastal area?
It looked like from Wayne's map, since we did that work, the USGS or EarthScope, or I don't know who, has installed many more stations in the coastal area than were available when I was working on the problem. I think also much of the data from Central California, including on the side of the fault that you care about, are campaign stations that haven't been reoccupied since 2009, and that's a pretty simple fix, to go in and reoccupy the stations. But I was not planning on doing it. And I just wanted to reiterate, it seems to me if you want to really see where you capture the full plate rate, it would be nice to get seismometers offshore. I mean, sorry, GPS offshore.
Is there any plans for any GPS offshore of California?
First of all, let me comment. Jessica, we're here. Go ahead. I'm sure she would emphasize this, that the data set that she has accumulated is available to anyone. And really, it's like any data. The more eyes that look at it with their own take, the better it'll be. And if you're interested in it, then, you know, just send Jessica an email and you can, it's yours. And the same would go for other people. And I expect over the next several years there will be others looking at it. As far as plans for offshore GPS, there are no definite plans. It's very costly. It would need a major investment from someone. It would not produce definitive results in 2 years. It would be a long-term investment. If Diablo Canyon is going to run for 20 years, it would seem to me that this is something that ought to be seriously considered.
Yeah, Phil Hogan.
In terms of possible sites for offshore GPS stations, I think Steve alluded to the possibility of putting a station on Techo Rock. I think that would be something that could be done at relatively low cost compared to trying to put something on the seafloor, for instance. Also, it might be worth considering some of the offshore oil platforms, such as Platform Irene in the Santa Maria Basin, Platform Hermosa or Hidalgo farther south offshore Point Arguello.
Yeah, we could use an oil platform in the Santa Maria Basin also, I guess, probably. But no, that's just a joke. Any other?
I have a follow-up question for Wayne. What is the forecasted level of funding and investment in the Central Coastal GPS network over the next 5 years, 10 years, and so forth? Is that an initiative that really has secured long-term funding from EarthScope to continue to expand the network? Do you think that the current setup of the campaign style and the semi-permanent sites is about where it will end up, or?
Well, first of all, the permanent EarthScope stations are in place and will remain operational. So that's quite an augmented network of continuous stations. We're probably not going to improve on the precision of the velocity vectors from those very much. We at the USGS, both in our internal program and through support with the USGS and PG&E CRADA, will continue to periodically reoccupy campaign GPS sites
and continue and hopefully expand these semi-permanent sites.
Yeah, you had a question? I'm sorry.
Yeah, my name's John Stamatikos. I work at Southwest Research Institute, and I'm here on behalf of NRC. I got a lot of questions. I won't get to all of them. One of them was that this morning we heard Norm say that the slip rate on the shoreline fault was largely based on that microseismicity data. So is that not right?
Yeah, the question was whether the slip rate on the shoreline fault, the degree to which that was based on looking at the rates of microseismicity.
Yeah.
That was one of several lines of evidence that we considered, but I wouldn't say that
Okay.
was by any means the overriding.
All right. Okay, so my question is, for the microseismicity on the Hosgri, how does that compare? Because when I was looking at Gene's plot, it looks like there's about an equal number of those relocated small earthquakes on the Hosgri as there is on the shoreline, but we know that they have very different, or we think they have very different slip rates. So has anybody?
No, we haven't made that comparison yet,
Okay.
but that's a good question.
Okay, second question I have is, especially for the geodetic people, and I'm not completely sure how useful this will be, but given all the seismic data, especially the hypocenter data, given the GPS data, given all the fault data, has anybody thought about doing a complete sort of 3D stress inversion to get an understanding of what the stress inversion would tell you about the kinematics?
Yeah, we've Jeff Unruh has received some funding to look at focal mechanism data sets to invert them for strain, not stress. And I think the first effort was around what was the falling state? Can you comment on that, Jeff?
We're running over time a little bit here too, so.
Okay, just briefly, we did a study for PG&E back in the mid-90s, I believe, looking at focal mechanisms from the Central Coast area, inverting them for components of a reduced strain tensor. It's very similar to inverting it for a stress tensor. And basically what we found is that the seismogenic deformation reflects kind of a transpressional shear, very much like what you'd expect from the regional deformation. And we took a second look at some of the more recent data last year, late last year, I believe, and there were different data sets, and we wanted to know there were some differences between the inversion of the more recent data set and the older data set, and we're still in the process of looking at trying to assess whether those differences are from different sorting of the data or whether there's actually different styles of deformation.
Just another quick one, John. We got to move on.
I'm sure I've got more opportunities.
We
tomorrow.
will definitely have more opportunities and more discussion because these are really